So this week we're going to start out with looking at 8.3 and 8.4. And then remember, we are skipping 8.5 and we will come back to it next academic week. And we're going to go to chapter 9 here on Wednesday. All right, so 8.3, writing complex numbers in what is called trig form. So we've worked with complex numbers before. Okay, the format that we've been used to using is something that would look like this. That's called standard form. Okay, standard form is when you write the real part first, then the imaginary part second. And if all you have to do with complex numbers is add and subtract them, standard form's fine. Okay. If you want to add two numbers that are in standard form, it's very straightforward. You basically combine like terms. Right? So like if you wanted to take that and add that to it, the first part has a real number that's 3. The second part has a real number that's 5. If you add them up, you get a real number of 8. We have a positive 2i, a negative 4i, and if you add 2 to negative 4, you get that. So adding and subtracting, very simple with standard form. Multiplying and dividing, not as simple. Okay? We've done multiplying and dividing, and we're going to review how you do it. But if we can learn how to write it in trig form, it's going to make multiplying and dividing complex numbers much easier. Okay. So I'll review how we've done it in standard, and then we'll learn how to do it the new way. Okay. So one thing we have to learn is if we're going to start writing complex numbers in trig form, we have to know how to graph a complex number. So I'm going to show you how you can represent a complex number visually. If you have the complex number a plus bi, okay, where the a and the b would be numbers, it's basically just like graphing the point a comma b. This number, comma, that number. That's all it really is. Because what we do when we graph a complex number is instead of using an x, calling it x in the y-axis, we just call it the real and the imaginary axis.
You go quickly?
Yep.
Please. Thank you.
So the real axis is going to take the place of x, and the imaginary will take the place of y. The directions are the same as what you're used to. On the real axis, positive numbers go right. On the imaginary, they go up. On the real axis, negative numbers go to the left. And on the imaginary, negative numbers go down. Okay. So I'm going to show you how we would use the complex plane to graph a complex number. All right, so let's graph negative 4 minus 2i. Okay, so we just have to remember, real axis is horizontal, imaginary is vertical. So you look at your number, first identify the real part. What is the real part of negative 4 minus 2i?
Negative 4.
Okay, so we're going to start out by going left 4, and then what is the imaginary part? Just the negative what?
Negative 2.
Just negative 2, yeah. So on the real axis, you're going to find negative 4. On the imaginary, you're going to go to negative 2. So what that means is left 4, down 2. And that's how you graph the point negative 4 minus 2i. That's it. Okay. What's important about graphing it? I'll show you that in a minute. How about this one? Negative 2 plus 3i. How would I graph that point starting at the origin?
Go over negative 2 to the left, and then up 3.
So left 2, up 3. Right there. That's negative 2 plus 3i. All right, how about 5i?
Over 0 on 5.
Right, there is no left or right, so if you want to think of it as 0 plus 5i, you could. There's just up 5. Okay. And 6. How would we graph 6?
Just be 6.
6 to the right. There's, again, if you're not sure because you don't see the imaginary part, if it's not there, you can just make it 0. Right? So it's 6 plus 0i. Okay. So any questions on graphing those points? So one thing that is going to be important that we know how to figure out is that distance. Now, we have a name for that distance when we do it in 1D. Right? If I had a number line, and I wanted you to measure the distance between 0 and 5, or between 0 and any number, there's a name for that. What do we call the distance from 0 on a number line? Absolute value. Yep. So absolute value is the distance from 0. Well, in 2D, we don't have 0, we call it the origin, but it's still the same concept. This line segment right here is the absolute value. If you can figure it out, it's the absolute value of that number right there. Okay? It's the distance that that point is from the origin, or from 0. Now, to find that distance, what do you think we would draw to figure that out? Triangle. Yeah, we're going to make a triangle. We're going to make a triangle by going like this and like that. What is the horizontal side in red? How long is that? How many units?
4.
It's 4 units long. How about the vertical side? How many units long is that?
2.
It's 2 units. If that side's 4 and that side's 2, how would you find the absolute value, which is the hypotenuse?
You could use Pythagorean theorem.
Yeah, we use Pythagorean theorem. Yep. And that's exactly what the formula is to find the absolute value of a complex number. Okay, so this is your complex number, where the real part was A, imaginary part was B. All you do is use the Pythagorean theorem with A and B, and that will tell you the hypotenuse. The hypotenuse is the absolute value. Okay. It's the distance from your point to the origin. It's just a new way to kind of think of like an application of Pythagorean theorem, but the formula itself is not anything we haven't done before. All right, because we are taking a square root, a couple things can happen. If you end up with a square root that can be simplified, like square root of 20, you should simplify that to like, what would that be? Square root of 4 times square root of 5, 2 root 5. Okay, you should always simplify the square root as much as you can. I don't think this will happen, but if you end up with a square root in the bottom, you should not leave a square root in the bottom of a fraction. But we're not. Well, we'll see. We could end up with square roots in the bottom. All right, so let's try an example of that. So it says find the absolute value of 3 plus 4i. First, can someone just tell me what's going to be my calculation I put off to the side?
Square root of 3 squared plus 4 squared.
Square root of 3 squared plus 4 squared. Okay, if you're more visual and you want to draw it out, you know, you're 3 units right and you're 4 units up. You're right there, and you're finding that distance. 3, 4. So what are we going to get for the absolute value of 3 plus 4i? Yeah, 5. And that's it. So another thing about absolute value is it always comes out to a positive number. Okay, you will never get, well, I'll say it this way, you'll never get a negative number. Could come out to 0 if the point you were finding was right at the origin. But as long as it's not that point, it will be a positive number. Any question on how we got 5? Now, I want you to think of that 5 one other way. Okay, you can think about it as being the absolute value of the complex number. You can think about it as being the hypotenuse. You could also think about it like that. If you thought about it that way, the 5 is really the what now of that circle?
Radius.
It is the radius. Okay? And it's going to be very important in a minute to think of that point as being on a circle. But that's it. That's how you find the absolute value of a complex number. So that's one thing that we need to know how to do to write something in trig form. The other thing we have to know how to do is figure out how much rotation did we do to get from here up to right there. In other words, you need to know how to figure out that angle. That's the other piece. So I'll talk about the angle right now. All right, I've been using the letters A and B, where A has represented the real part, and B represents the imaginary part. Okay, I'm going to switch to using X and Y now, okay, because I think if I use X, you'll be more likely to remember X is horizontal, and that's the real part, and we know Y is vertical, and that's the imaginary part. Now, I also put the I before the Y. We usually put the I after the number. You could put the I after the Y there too. But I'm going to be coming up with a formula, and I'm trying to make it match with what's in your book. And the way they do it, they put the I in front of the Y. It's the same thing. Okay. When you write a complex number this way, what form did I say this was called? This is standard form. In standard form, you are allowed to use an X and a Y. In trig form, you are not. So what I have boxes around, those two things need to go away. We need a different way of writing X and Y. And that's where this diagram is going to help us. So I want to think of that point now as being on a circle, just like that. One way to describe how to get to this point is to say move right X units and move up Y units. That's standard form. Now we're going to describe it in trig form. What two letters do you think are going to be involved in trig form? They're in the diagram. R and theta, yeah. So we're going to have to use the R and the theta somehow to describe how to get to this point, not the X and the Y. So let's see if we can come up with an equation that will allow us to convert an X into something else and a Y into something else. Let's start with X. What trig function would relate this side and this side? If you're not sure, think about the position of this side, think about the position of that side, and then ask yourself what trig function has those two in it.
Cosine?
Cosine, yep. So we're going to start with cosine. And the cosine of my angle would equal what over what?
X over R.
It would equal adjacent over hypotenuse, which is x over r. Now, solve that for x. And that will give you a different way to write x. What would you get if you solve this equation and get x by itself on the right? Yep, r cosine theta. So this gives you a way to describe the horizontal without using the letter x. We're going to fill that in. Now we're going to do the same thing for y. I want you to use that, that, and that. What trig function could I use that would relate sides y and r? Could use sine. Okay. So sine is opposite over hypotenuse, which means y would equal r sine theta. So now we have a way to describe the vertical, the up and the down, without using the letter y. We can say r sine theta instead. Right? So we're going to make these two substitutions for x and y. Once we do that, that's going to give us the trig form. Okay, so instead of x plus iy, change x to r cosine theta. Change that to r cosine theta. And change that to r sine theta. Now, once we do that, we have two terms. That's a term, that's a term. What does each one of those terms have in common for a factor? R. Okay? Each one of them is multiplied by something that has at least an R in it. When two things have the same thing in common as a factor, you can factor it out. If you distributed this back out, you'd have r cosine theta plus I times r sine theta. And that is the trig form of a complex number. R, and then in parentheses, cosine theta plus I sine theta. Now, at first, you might think, well, that looks a lot more complicated than just doing this standard form right up there. If you were going to add and subtract, I would say, yeah, I've already told you, this is the best way to do it. Trig form's not going to help you do anything better. But if you have to multiply and divide, this is a lot easier. So what would something look like in trig form? Like a final answer. Just making this up. 8 cosine 30 degrees, I sine 30 degrees. That's an example of what a final answer looks like in trig form. You don't do it out. You leave it just like that. If you do it out, then what you're doing is you're changing, like if I did this, took the cosine of 30 and times 8, and then took the sine of 30 times 8, I would be changing it back to what I started with. So if you want to check your answer, you could do it out. But if they say to write it in trig form, you stop there. You do not distribute that out. So to use this form, you don't have an x and a y in it. What are the two letters that you do have? Well, those are functions. What are the two variables you have? Remember, I is not a variable. I is a number.
R and theta.
R and theta, yeah. So R and theta are the two variables. So you need to be able to figure both of those out. Well, R is what I just showed you how to do in the first couple problems. Right? That's the absolute value of your complex number. It's the hypotenuse of a triangle. Okay, so that's how you get the distance from the origin. And now we just need to talk about how do we get theta. Well, let's think about how we would get theta. So first thing we'll do is we'll draw a triangle. And we can use Pythagorean theorem. That's easy to get R. So now you're going to be given the x and the y. Okay, that's standard form. You will have those two pieces of information. If you know this and you know that, what trig function would relate the two sides that I just circled?
Tangent.
Tangent. Yep. What would tangent equal?
Opposite over adjacent, so y over x.
Would equal y over x. Yep. And now our goal is to figure out the theta, not the tangent of theta. So how would we get rid of tangent? Yep, I'm going to take the inverse tangent of what's on each side. Oops. Take the inverse tangent. What happens on the left?
Tangents cancel
And-
and theta's left.
And theta's left. So that's gone. And you get a formula to find the angle, or you can think of it as the amount of rotation that you had to do to get up to that point. That's what theta is. It's an amount of rotation. Okay. So inverse tangent of y over x. Now, the problem with inverse tangent is inverse tangent will always give you an answer when you type it in between negative 90 and positive 90. What two quadrants does that mean inverse tangent is limited to? One?
And
4. Yes. Negative 90 is down here. Positive 90 is up here. So the issue with inverse tangent is it only works on half the diagram. Inverse tangent by itself does not work in quadrants 2 and 3. If I had answers on that half of the circle, and I wanted to shift them to the other half of the circle, what could I add to any of these answers, and it would shift them to the other half?
negative signs.
Okay, if you made the x value of the coordinate negative, yes.
60.
I want you to think of what that's equivalent to as a rotation.
180.
Yeah, but yes, making the x coordinate negative is a 180-degree rotation. Yep. So when we get to quadrants 3 and 4, we're going to have to add quadrants 2 and 3. We have to add 180. Okay, but for quadrants 1 and 4, inverse tangent will work fine by itself. Okay, and it does have to be inverse tangent of y over x. If you do x over y, you're going to be finding the wrong angle. You will be finding an angle, but it's not the one that you want. It would be the other one in the triangle, because you'd be mixing up your opposite and adjacent. Okay, so that covers quadrants 1 and 4. Pythagorean theorem covers everywhere. That's quadrants 1, 2, 3, 4. Doesn't matter. Okay, quadrants 2 and 3. You can still do inverse tangent, but then you have to shift those answers over to the other half. And to do that, we add pi if you're working in radians, or 180 if you're working in degrees. Now, that still doesn't cover everywhere that an angle could be. You've got quadrants 1, 2, 3, and 4 covered. But where else could a coordinate end up besides quadrants 1, 2, 3, or 4?
Oh, on the origin.
Well, it's always going to be on a circle that has a size to it, so it'll never be at the origin.
Axis.
But it could end up on an axis, yeah. It could end up on an axis. And if I ended up right here, I don't know the y value. It's up. I don't know, maybe it's up 3. But what's the x value right here?
0.
It's 0. The x value is definitely 0 if you are on the y-axis. If the x value is 0, and you try to plug it into one of those two formulas, what would happen?
It would just be 0. It would be undefined. Undefined.
Be undefined, because you'd be trying to plug in a 0 for the x value in the bottom of a fraction. So you cannot use those formulas when you are on an axis. So what do you have to do? Well, you have to memorize the answer. Okay. When you're on an axis, it's either 0, 90, 180, or 270. In radians, that's 0, pi over 2, pi, 3 pi over 2. And those aren't angles we're unfamiliar with. We've used those a lot. Okay. So now, if you're on an axis, you know how to get the coordinate. Well, you know how to get the angle. You just memorize it's one of those 4. If you're not on an axis, that's a little bit more work. You got to do the inverse tangent. The other nice thing about being right on an axis is you don't really need Pythagorean theorem to get the distance to the origin. You can just count 1, 2, 3. Right? When you are on an angle, well, you can't count on an angle. That doesn't work that way. So then you got to use Pythagorean theorem. So even though landing on an axis is a special case, it's actually a lot quicker and easier. All right, so any questions on how you get R or how you get theta? Okay. So let's try it. And then once we understand how to write complex numbers in trig form, then I can finally show you what trig form is really fast at doing. Okay, but we got to know how to write it in trig form first. All right, so -2 plus 2i. What's the first thing I should do with this coordinate? First thing I showed you today. That's going to make this a little easier to think about. Let's graph it. Yep. So -2 plus 2i. Where is -2 plus 2i?
Over to the left and up to.
Left 2, up 2. This is why I showed you guys how to graph, because it's important to know the quadrant. Because the formula for theta is going to depend on the quadrant. Let's make our triangle. Okay, but I'm just writing the lengths. I'm not actually writing the -2. I know that's just the direction. Okay. Each side is 2. So that means my radius is going to be the square root of
2 squared plus 2 squared.
2 squared plus 2 squared, which is?
Say again, 2 squared plus 2 squared?
2 squared plus 2 squared.
4.
It's 8.
8. Yep. So the radius is the square root of 8. And then, because that's a number we can reduce, what's the square root of 8?
2 square root 2.
2 square roots of 2. Yep. Okay. So that's half of what you need to write your answer in trig form. So you got your R. What's the other letter you need?
Theta.
Theta. theta, if you want to think of it on a circle, you're trying to figure out how much rotation do you have to do from here to get to here. So that's how you're describing this point to me. You're telling me to go out that far on the circle and then rotate that many degrees. All right. So what's our formula for theta in the quadrant that that point is in?
Theta equals inverse tangent y over x.
Pi plus inverse tangent y over x.
Yeah, we could do pi if we want to do radians. What if we want to do degrees?
180.
Yes. My advice would be to generally do it in degrees first, because if you get a nice answer, you can convert it yourself. Okay. All right. Now let's fill that in. Okay, what's y in this case?
2.
2. And what's x?
Negative 2.
Negative 2. So it's the inverse tangent of negative 1 plus 180. 80 plus inverse tangent negative 1, and that gives you 135. So that's your answer. Now, put those two pieces of information together to write the final answer. Final answer looks just like what's in that box. Just fill in what we got for r and what we got for theta. Okay, so we've got r cosine 135 plus I sine 135. That's your final answer. Okay, any question on how we got that? Now, let me type that in and watch what happens. If I do 2 root 2 times the cosine of 135, what number do you think I will get?
Read that.
If I multiply 2 root 2 times the cosine of 135 and distribute it out,
Would it be 2 times the root 2 cos 135 plus?
so give me a single
It's going to
number.
be negative 2 plus 2i. It's going to.
So it's going to be which number?
It's going to go back to the original.
Yeah, so and specifically, when I multiply it by just the cosine, I'll do the sine after. What's 2 root 2 times cosine 135?
Negative 2.
It will be negative 2. Yep, it changes it back to what you started with. And if I do 2 root 2 sine 135, what number is that going to give me?
2.
That's going to give me
2i.
2. And then, well, the I is going to be next to it right there. But 2 root 2 times sine 135 gives you positive 2. So the negative 2 and positive 2, you can confirm you did it right if you change it back. So we know we did it right. All right, any question on that one? Now, normally I'd practice a couple more, but we're still going to have to do this to do the next thing. So we're going to practice a couple more of these anyway. All right, so the last thing, what does this really help us to do? Well, writing complex numbers in trig form gives us an extremely fast way to multiply and divide complex numbers. Let me just make up 2 complex numbers. You don't have to write this. I just want you to watch me multiply them together in trig form. You don't know how to do this yet, but I think you'll see how to do it just by me writing an example. If I wanted to multiply these together, the answer would be 6 cosine 40 I sine 40. If I wanted to divide those two complex numbers, it would be 2/3 cosine 20 plus I sine 20. Now, maybe you can tell what I did. Maybe you don't know quite exactly what I did to get these two answers. That's fine. I'm gonna explain how I did it. But I wanted to show you how fast I could do it. That was the point. In trig form. Now watch how long this is going to take to do in standard form. Okay, we're going to review how to do this in standard form, not trig form. Okay, so this is what's coming in a minute. All right. So to do this in standard form, okay, we're going to do division. We have to multiply the top and the bottom by something. So that's the first thing you have to remember. When you do division with complex numbers, you don't really do division. You do multiplication. And does anyone remember what you multiply the top and the bottom by?
Is it the inverse reciprocal for the reciprocal?
No, it's not reciprocal. We do multiply by reciprocal for lots of other things, though. But it's not called the reciprocal here. Anyone remember what it's called? We used this when we did trig identities too. This was one of the tricks I said. To multiply by the something with the denominator. We have to do something to it.
Inverse of the denominator?
Kind of. It's not called inverse though. It begins with a C.
Common denominator.
Not common denominator. It's a single word. One word.
I know. It's like change the sign.
Change the sign of what's in the middle, yeah?
Oh.
There.
Yeah, I do.
Begins with a
Conjugate.
What is it?
Conjugate.
Conjugate, yes.
Ah.
All right, so we got to remember to multiply the top and the bottom by the conjugate. So now my next question, which we answered, what is the conjugate? It's when you do what?
Change the sign.
Change the sign. So if you change the sign, what do you get in this one?
5 minus I.
So we have to multiply top and bottom by 5 minus I. Now keep in mind, I had already multiplied and divided. I was done way before this point already. So this is taking a while. I mean, we'd have to remember what it was called. But. All right, so we got 5 minus I. Now, we have to distribute all that out. In the top, it's not even as bad as it could be. It's just a single distributive. Right? When you distribute out the 3 in the top, what do you get?
15 minus 3i.
Okay. Now, if that had been like 3 plus 2i, then we would have to FOIL it, like we do in the bottom. Okay, so in the bottom now, 5 times 5 is how much?
25.
25. And then 5 times negative I.
Negative 5i.
And then 5 times I.
Plus 5i.
Plus 5i. And I times negative I.
Negative squared.
Negative I squared. And at this point, we had already finished that problem 3 times over now.
So negative I squared just 1.
So now we got to keep going. So 15 minus 3i. We got to combine like terms. Negative 5i, positive 5i is gone. We get 25. And what did you say I squared is?
Just 1.
Well, I squared is negative.
I squared is
Negative
negative
1.
1.
So negative, it would just be positive 1.
So it's going to be minus minus 1, which is plus 1. So there's another thing we had to remember. I squared is negative 1. And now we need to put that as real part and imaginary part separate. So 15 over 26 minus 3 over 26i. Okay. That's doing that whole problem in standard form. Right. Now, I'm going to show you how to do it in trig form, which is what I did right here. If the original problem is not given to you in trig form, then no, trig form is not going to save you any time. If the original problem is given to you in trig form, like they help you out and give you those numbers, then it will save you a lot of time to multiply and divide. All right, so kind of going back here, this was the multiplication. Does anybody see what I did
Yeah.
to get that from that?
Yes.
Yeah, what did I do?
You multiplied the 2 and the 3 and then added the cosines together and the sines together.
Yeah, so I multiplied the two numbers in front, and then I added the two angles on the inside. Yep. So that's the formula for multiplying two complex numbers together in trig form. That takes away all the foiling, takes away any I-squareds you have to worry about, combining like terms, and it reduces all of that to two steps. A multiplication and an addition, both of which can be done on the calculator if you even need to use one. And now the division, that's what we did in this problem. You had to find the conjugate, multiply the top and the bottom, FOIL it all out, deal with the I-squared, combine like terms, and then write it as two separate fractions. There's a lot of steps there. How did I get this from the example I gave you right there?
You divided the 2 and the 3 and then subtracted the cosine 30 from the cosine 10. You just subtracted the 1 on the bottom.
Yeah, I just divided my two radii and I subtracted my angles. Divided my two radii, and I subtracted my angles. So what I think I'll do, you know what? I'm going to go back and look at the problem we just did. I'm going to change it to trig form, and I'm going to do it that way. And because we already did it, then I can compare my answer and show you that it does come out exactly the same. So let's do this one, 3 plus 5i. Now, to do that in trig form, I do have to change each one of these numbers into trig form. Right, so that's like what we did in example 3. So we're going to have to do example 3 twice. But the top number is easy to change to trig form. So let's start with the 3. What's the imaginary part of 3? 0i, there isn't one. So if I graph it, how do you graph 3?
Just right through or
Just go right 3. If you go right 3, what's your radius? 3. And you don't need inverse tangent to find your angle because you're on an axis. What's your angle if you're right there?
0.
0. Yep. So this one is very easy to write in trig form. It's 3 cosine 0 I sine 0. Here's your first one. Now, let's do the bottom. Let's write that one in trig form. All right. Where is 5 plus I?
Go to the right. 5.
Yep.
And then up. 0.
Up 1.
Up 1. Okay, so 5 plus 1i. So right 5, up 1. Make your triangle. Use Pythagorean theorem to get your radius. What's my radius going to be?
Square root of 25 plus 5 squared plus 1 squared.
Square root of 26.
Square root of 26. Yep. Okay, so my radius is square root of 26, which kind of already knew, if you remember the last problem, we got that 26. That kind of has something to do with the radius. All right, so we get square root of 26. And my angle, what's the formula for the angle in quadrant 1?
Square root of
Theta equals inverse tangent y over x.
Inverse tangent, and in this case, y over x will be
5 over an I. 5 over. Oh, that would be I over 5. So 1 over 5?
1 over 5.
Oh, okay.
So y and x both have to be numbers. We don't use an I when we do inverse tangent. Okay. All right, so let's get our angle. It's not going to be a nice number. But to keep it accurate, I'll go 3 decimal places. Actually, I'll do 2, because it's going to round up to 11.31. All right, so that's my angle. All right, so that one in trig form is r cosine 11.31 plus I sine 11.31. Okay, so there's my first number in trig form. There's my second number. Now, let's divide them, okay, and do it in trig form and see if we get this as our answer. Okay. If I want to divide them, what am I going to do with the 3 and the root 26 to plug them into the bottom formula?
Multiply by the conjugate.
3 divided by root 26.
Yep. So R1 is 3, R2 is root 26. That's 3 divided by root 26. Should I leave the root in the bottom? No. I'm not really getting into that right now. Okay, so I got 3 over root 26. And what's my angle in the top? 0. What's my angle in the bottom?
11.31.
And when I divide, what do I do with the 2?
That would be negative, or cosine negative 11.31.
And what did you say the rest was?
And then plus I sine negative 1.31.
Okay, so that's the answer when you divide those in trig form. Besides finding what was in the red boxes, notice how quick it was to do that. You just had to take that number divided by that number, and that angle minus that angle, and you were done. Did it take a little while to get what was in the red boxes? Yes. Yeah. I told you it's only really fast if they give you trig form, which in the next problem, I do. I'll give you the trig form. Now, let's see if what we got is the same. 15 over 26. Okay. We're going to get decimals, so I need to see what 15 over 26 is.
0.57.
Okay, so 0.5769.
I prefer the freaking.
And negative 3 over 26 is negative 0.115. Okay. Let's see if we get those 2 decimals when we check our answer. Okay. Take square root of 26, square root of 26, and multiply it by the cosine 11.31. If we did it right, I should get 15 over 26. Cosine 11.31. That's that 0.576 number. Oh, what did I forget? I forgot my negative.
Yeah, you forgot, yeah.
I thought I wrote the negative in.
Oh, because
Oh, I did.
You were using, yeah.
Yeah. Let me type it in again. So cosine, I looked at the wrong thing. Negative 11.31. We're looking for 0.5769.
You need 3 root 26.
Yeah, you 3 divided by.
over 26.
Yeah,
Okay,
3
this is
divided
rough.
by.
You have to type in your answer if you want to check your answer. If you type in something that's not your answer, you're not checking your answer. So,
Wait, no, but no.
why is that extra parenthesis there?
Oh, yeah.
There we go. So 3 over root 26 times cosine negative 11. Now, let's see if we get 0.5769. We did, right? So when I multiplied it out, I got exactly the same thing that I did the first time. And now the other number was negative 0.11538. Let's see if we get that. So I just have to type in the same thing again with the sign. Negative 0.11538. It's exactly the same number. Yep. So doing it in trig form or standard form gave us the same thing. All right. Let's try another multiply, but this time you don't have to find the two numbers. I'm giving them to you. And I only did 2 decimal places, so you can match what I did. Just stick with 2 decimal places. Okay, so let's try multiplying them. What is R1? 5. What's R2? 2 root 2. When I want to find this, what do I do with R1 and R2? Multiply them. What's 5 times 2 root 2?
10 root 2.
Yep, 10 root 2. Okay, so that's half of it. Okay. What is theta 1? 0.93. What's theta 2? What do we do with theta 1 and theta 2 to figure this out? Add them. Yep, so 0.93 and 2.36. What does that come out to? 3.29. All right, so that's multiplying. And now let's do dividing. What's going to be my radius when I divide?
5 divided by 2 root 2.
Okay, so now we've got 5 over 2 root 2. What do you multiply by to fix it so that root 2 is not in the bottom? Well, what's the only thing you can multiply by and it doesn't change a fraction? 1. So you have to multiply by something that's the same as the top of the line.
Or just root 2 over?
Just root 2. So not the conjugate. We're not doing that in this one. Okay, it's a little different. So this is just simplifying. It's just arithmetic to get rid of the root. What do you get in the top when you do that?
5 root 2.
5 root 2. And in the bottom?
Over 2. Over 4.
Over 4. Yep. Okay, so there's your radius. That's fine. Now, what's going to be the angle?
Negative 2.36.
Okay, and how did you get that?
I subtracted the cosine 2.36 from 0.93.
Okay, so you subtracted 2.36 from 0.93.
And you got negative 2.36. How does that necessity? It's negative 1.43.
Let's just double check it. 2.36. Actually, no, you did it this way. 0.93
Yeah, 0.93.
minus 2.36.
How did you get negative 2.36?
So everything sounded right?
2.9.
But yeah, negative 1.43. Okay.
My bad. I subtracted the wrong number.
Now, I don't know if you noticed or not, but there were no labels on the angles in this problem, which means what? Means they did this one in radians, which is fine. But when you write your final answer, they may ask you to leave the angle positive. There's 2 ways we can fix having a negative angle. If they don't say anything about leaving a negative angle, then that answer's fine. If they say not to, then that answer is not fine. What's one thing you can do to make a negative angle positive?
Add 180.
Or add pi.
That's fine.
Add 360 if you're in degrees,
Oh, add 2 pi.
or add 2 pi if you're in radians. Okay, let's do it by adding 2 pi. So that gives you a new angle of 4.85. Okay, so if they ask you to get rid of the negative, that's one way to do it. You can add 2 pi, or 360 if you're in degrees.
When do we know when we're supposed to be adding pi versus 2 pi?
Well, this is basically adding a revolution to the point. So this is a totally different kind of concept from going back to like unit circle. If you're working with an angle and it went around more than once, that does not change the coordinate.
Right.
Going around more than once means you add or subtract 360.
Right.
So when you're trying to deal with a negative angle and make it positive, you can add 360 or 2 pi. If you're trying to deal with the angle in the quadrant, that inverse tangent y over x, this plus 180, that's a totally different concept.
That's great.
Yeah, that's inverse trig. That has nothing to do with the adding 360 stuff.
Okay.
They're totally separate lessons. This is when we added 180 today. Okay. Any question on that one? Okay. So that's how you can multiply and divide complex numbers in trig form. So homework. Let me just double check that. Make sure. $450. Okay, so up to number 14, it doesn't do anything more complicated than graph the point. So those are pretty quick. 17 through 20, you're writing in trig form. 33, you're multiplying. 34, you're dividing. And yeah. So that's it.